All right, so looking on the front of this, right, you have three things that have to be true in order for it to be continuous, right? What's the first one? Well, that's true, but like look at literally what exists. The point and a limit. The point has to exist, the limit has to exist, and then they have to be equal, right? Point exists, limit exists, they have to be equal. Those are our three things, right? So we're going to look at these piecewise functions. It says in dealing with continuity of piecewise functions, which is what we have here, we need to examine the x value where the rule changes. So we're examining what happens at 1. Does that make sense? So the easiest thing to figure out is if f of 1 exists. So let's start with that. F of 1, what would f of 1 be? Negative 2. And you know to substitute it into this one, right? Negative 2. The point exists. Perfect. Okay? Then we need to check and see if the limit exists. So that means I need to take the limit of f of x as x approaches 1 from the left, and the limit of f of x as x approaches 1 from the right. Okay? We good with that? So when we do this one, we can, from the left, which one am I using? The first one. So when I substitute in 1, I can just substitute it in, I get negative 2, right? When I substitute it in this one, what do I get? 0. Okay? So does the limit exist? No. So it fails right there. All right, so we can say the function, or we could have said f of x, either way, but I already wrote that, is not continuous at x equals 1 because the limit as x approaches 1 of f of x does not exist. Okay, make sense? You have to write it out. You don't get to just show it. Okay, we okay with that? Well, I wrote out does not exist, so you really could put D and E right there. Or you could put this equals D and E, that would be fine too. Okay? Therefore that makes it that's what makes it discontinuous there. We good on that? Okay, perfect. So let's look at the next one. It says let f be the function defined above if f is f continuous at x equals 1, why or why not? Okay. So the first one we want to do is just what's f of 1? Let's see, does that exist? Yeah, it's going to exist, so we need to figure it out. So we would substitute, this will give me 10 minus 2 minus 1, right? 7? Okay, so the point exists. Check. Then we're going to check the limit. The limit as x approaches 1 from the left of f of x, and I'm also going to need the limit as x approaches 1 from the right of f of x. Okay. So let's see if we could, it looks like we could just do that with substitution, right? Won't I get the same thing here when I substitute this in? So that's just 7. Then when I do it from the right, this is going to be 4 times e to the 1 minus 1, which is 0, plus 3. What's e to the 0 power? 1, so this equals 7. Okay? Does that make sense? All right, so then we can say that okay, so I can say f of x is continuous at x equals 1 because the limit as x approaches 1 of f of x equals f of 1, which equals 7. That's your definition of continuity. The point exists, the limit exists, and they're all equal to each other. Boom. Okay, do you understand how to explain those things? Any questions at all? Okay, so that's one way to use it. Grab your notes for today. Let's look at another way we are going to use it. There we go. So this one goes on 29. Yes? Okay, so we're going to kind of narrow down this definition. We have it written all fancy on the other one, but what this boils down to is, 1, the point exists. Let me actually write the word. Point exists. Limit exists. Oh, goodness gracious. Point equals limit. Right? That's just the bare bones of, I mean, you got to say it more formally when you're showing it, but that's what you need to remember. The point exists, the limit exists, the point and the limit are equal. We good on that? Okay, so this says prove that it is discontinuous at x equals 2 if a equals negative 4. So my question is this function continuous? No, because it says prove that it's discontinuous, right? So obviously it's going to be discontinuous. Actually, oh, I'm looking at the wrong one. Okay. Let's see. Woo. Okay. So here's what we're going to do. We're going to find first, remember when we're doing piecewise, we use where it changes, and this is where it changes. So we can find f of 2. What's f of 2? 1. Okay? So there's the point. Boom. Now we need to find the limit. The limit, as x approaches 2 from the left of f of x, and then the limit as x approaches 2 from the right of f of x. Okay? And so we have an a and an x in there, but it says a equals negative 4. So I can just put that in there, right? Basically, this changes to negative 4 right there where the a is. Okay? So when I do it from the left, I'm going to substitute in 2 to here, right? So I'm going to get negative 4 times 2 plus 7. What's that going to give me? Negative 1. When I do it from the right, that's still going to be negative 4 times 2 plus 7, right? Because isn't this just a line with a hole in it? And that gives you negative 1. So the limit exists. The limit as x approaches 2 in general is equal to negative 1. So the limit exists. We have the point exists, the limit exists, right? What did I say? Oh, yes, dang it. What always? F of x. Thank you. Yes, I'm missing f of x equals. There we go. Thank you. Yes, that's important. Check my notation if I got this wrong. So is this continuous? No, these two things exist, but it doesn't work that way, right? So we need to say, oh, God. So we need to say the limit as x approaches 2 of f of x, I leave that all the time, does not equal f of 2, okay? Then we're going to do this. Do we know what that means? It's not a gang symbol. What does it mean? This means therefore. Because that's the symbol for therefore. Good. Okay. Therefore, all right? That's what it means. That way you don't have to write out the big old long word. You're saying, therefore, f is not continuous at x equals 2 if a equals negative 4. This is your answer, but your work backs it up. Okay? Your wording and notation is important. You have to be able to say what you're thinking and say what you mean. Symbols are okay, abbreviations are okay as long as they make sense to anybody that would read this, but you got to make sure that we're using the definition of continuity to show that. Okay? We're okay on that? What questions do you have? Lorenzo, you got a question? Sure? I don't know that I believe you, but okay. All right. You can tell by looks on your faces. All right, so this says use the definition of continuity to find K so that F will be continuous. Okay, so we want this to be continuous. So I can find the F, I want F of 2. F of 2 would be what? 5. Okay. So that exists. Check. So then I'm going to do the limit of f of x as x approaches 2 from the left, and the limit as x approaches 2 from the right of f of x. I think my problem is I'm not consistent about whether I write this part first or this part first, and if I don't write this first, I forget to write it sometimes. I got to check myself on that. Okay, so I'm looking for this. As I go from the left, that's this one, right? It's going to be 5, right? As I go from the right, it's going to be this one, and that's going to give me 2k plus 6, right? Because I don't know what k is. Makes sense? If this is going to be continuous, which is what I want, don't these two have to be the same? Right? That means what I need is I need 5 to equal 2k plus 6. So then that'll give me negative 1 equals 2k. So k is equal to negative 1/2. Okay? Everybody okay with that? Make sense? All right, so then we say, when k equals negative 1/2, the limit, oh, that's not a no. The limit as x approaches 2 of f of x equals f of 2, which equals 5. Okay? The limit exists, the point exists, the limit and the point are equal. That's what's happening here. Therefore, f is continuous when k equals negative 1/2. Oh, f is continuous. Oh, I left off something important. Continuous at x equals 2. It's not necessarily continuous all the time. I mean, that's all we showed is that it's continuous at x equals 2 when k equals negative 1/2. Okay. What questions you got? Okay. Okay, so this time we have to find A and B so that f will be continuous everywhere given. Okay? And we have to check this at where it changes. So it changes at negative 3 and it changes at 1. So that means I need to find f of negative 3 and I need to find f of 1. Okay? So what is f of negative 3? Negative 17. And then what is f of 1? You sure about that? Yeah, it's the middle one. Here's where 1's included, right? So if I substitute in 1 for x, I actually get a plus b. I don't know what those are yet, but I feel like for sure this one exists. That one's probably going to exist. So I feel like I can move on. I don't know enough yet to be like, no, it doesn't exist. I got to figure out what a and b are. I'm thinking if I can find those numbers and they're real numbers, then that one will exist. So we have to do two things. We have to look for the limit as x approaches -3 of f of x. So we have to find this. And we have to find the limit as x approaches 1 of f of x. Okay? We'll come back and fill those blanks in. So in order to do this, we have to do the limit as x approaches -3 from the left of f of x, the limit as x approaches -3 from the right of f of x. Then I'm also going to have to do the limit as x approaches 1 from the left, and the limit as x approaches 1 from the right. Everybody with me? Okay, so let's start back over here. The limit as x approaches 3 from the left. What's that? It's going to be -17, right? Oh, God. I forgot this was happening. That's okay. Look, y'all got to all find me. You know what I look like? We're going to go down here and go across over there. Okay, I'm going to have to go back and edit out. I'm at least going to edit out the fire drill sound because it's probably horrible in a video. So I'm not even sure what the last thing I said was. But we were finding these limits. So when we find the limit from the left, okay, this one right here, it's just -17. So now we need to find the limit from the right of -3. That's going to go in here, right? So can I just substitute in a -3 for x? Yes. So that can just give me -3a plus b. Don't haunt me on an Algebra 1 type situation. Okay. So what I want is for this limit, these two need to be equal because I already have a number here. It needs to equal -17, right? So that means that -17 has to equal -3a plus b. Yes? Okay. We'll come back to that because we have two variables. So now we look over here. The limit as x approaches 1 from the left is going to be what? A plus b. No, because I'm substituting in the 1. Yeah, does that make sense? Okay, no, that's good. And then from the right, what's my limit? 3. So that means this limit overall needs to be 3. In order for that to happen, I need 3 to equal a plus b. Yes? What do I have here with two equations and two variables? I do. What is this situation called when we're trying to solve it? Substitution. Okay, I can do substitution. What's another option? Elimination. It's a system of equations. That's what I was trying to get at, but that's fine. As long as you know how to do it, whether or not you can say it, totally fine. All right, so system of equations. So that means I have -17 equals -3a plus b, and 3 equals a plus b. And I don't care if you do substitution or elimination, it doesn't matter. This one I feel like is set up pretty good for elimination, wouldn't you? Okay, so I would take this and multiply this whole thing by a -1 right there. That way, when I do this, this will be -17 minus 3, which is -20. And then -3a minus a is -4a. And b minus b zeroes out. So that means that a would equal 5. And if a equals 5, I can just look right back here. What would b have to be? -2. Okay? Everybody good with that? Okay, so then I can go back and check this out. I already know that these have to be like this, right? And then I have, what I'm looking for here, this a plus b. This equals 5 plus a negative 2, which is 3, which is what I wanted for that, right? So this exists. Not only do these both exist and both of these limits exist, the respective limits equal the respective points. Make sense? So now I have to say all of this stuff. Here we go. Let's see, I'll do it in orange. We will say, when a equals 5 and b equals negative 2, the limit as x approaches negative 3 of f of x equals f of negative 3, which equals 17, right? And the limit as x approaches 1 of f of x equals f of 1, which equals 3. Okay? Since those things are true, that's where we say, therefore, f of x is continuous everywhere when a equals 5 and b equals negative 2. Okay? So it's fine to mix the symbols and the words as long as you are saying what you need to say. So here we have said, we know this, all of this satisfies the definition of continuity. Since this satisfies the definition of continuity, I know it has to be continuous. That's what's happening with our explanation there. Okay, we good on that one? What questions you got? Okay, so the last one we're actually going to do after tomorrow's lesson because it kind of goes, like I could have done tomorrow's lesson today, but I decided to do today's lesson today. But you kind of need this for the next one. So I'm going to give you your assignment and you can start working on this.